Hello. Good morning and welcome everybody, and thanks for joining us in this event organized to introduce the special issue of the Journal of Cultural Heritage. As you know, if you don't know, you can consult our website. The journal is a multidisciplinary publication of science and technology, of cultural heritage, of conservation, awareness of cultural heritage in a wide framework. Actually, heritage science is a complex field that is intrinsically multidisciplinary, or better, interdisciplinary. Conservation needs a global approach to the object to be restored, because we have to start from the knowledge of the tangible, intangible aspects, and then go into conservation or restoration, including issues such as social issues and economical issues. I think this is particularly true when we are dealing with such an iconic monument as Notre-Dame de Paris. Notre-Dame de Paris, when the fire broke in Notre-Dame in 2019, all the people was shocked and were really touched in their hearts. And the following restoration needed a very careful approach, because it was a very challenging task, and it was made with the creation of a task force of many different experts from diverse fields and disciplines. I think this is reflected in the papers that this collection of paper, I think, reflects this extraordinary effort of all the people that work, all the experts from these different disciplines that work on this extraordinary monument. And I'm happy to introduce this special issue, because it does not only provide a good picture of this work in progress, but also of this, that I was saying, that heritage science is a really intrinsically interdisciplinary field. And that's the approach that is needed in these cases. So that was a very brief introduction, because I want to leave to make room to the speakers. But first of all, before introducing the first speaker, I would like to thank a lot Dr. Livio De Luca, who is an editor of the Journal of Cultural Heritage, and who proposed this special issue and dedicated a lot of effort and time, together with the guest editors, to the creation of this special issue. Now, there has been a change in the program, and the first presentation will be done by Ludovic Lebeau, General Deputy Director of the public establishment in charge of the restoration of Notre-Dame de Paris. He will speak about the Notre-Dame restoration work site, scientific challenges and opportunities. So please, Ludovic, you can start.
Morning, and thank you very much. Can you hear me? Good morning. Yes, very much for giving me the opportunity to exchange with you today. And I would like to start with a few words about the restoration project of Notre-Dame de Paris. The restoration of the cathedral is on a good way. Its reopening to worshippers and the public will be realized by the end of 2024. This challenge is followed by a wave of generosity, hundreds of thousand donors from approximately 150 countries. After an initial phase to secure the building, completed in the summer of 2021, work is now focused on its restoration. Notre-Dame de Paris is being on the upper parts of the outside of the cathedral. The spire is now rebuilt. Stone cutters and sculptors have been laboring for many months to restore the gable walls and areas and gargoyles that were damaged by the fire. All the vaults have now been restored or rebuilt. At the same time, the interior restoration work is continuing to progress, involving many artisans and artist workshops. So we pay tribute to the talent, know-how, and commitment of a host of nearly 1,000 artisans in the earth of Paris and also in workshops all around France. They have been working with passion through 250 project tenders awarded by the public establishments. And to support this restoration project, the link between the scientific action and the restoration was essential. It was one of the conditions for success. The fire that devastated Notre-Dame in April 2019 turned a new page in its history. Certainly painful, but it opens also a privileged moment for the observation and study of the monuments. That's why a national scientific action, Notre-Dame, coordinated by the CNRS and the Ministry of Culture, was launched early in 2019. This national scientific action considers recovering the knowledge about the architectural elements and material before the fire, extracting and saving the scientific information contained in the preserved materials, modeling systems for geometric, structural, and acoustic studies. It comprises 175 research staff from 50 research units organized around 9 working groups, wood, metals, and also stone, glass, structure. And this scientific work in support of the restoration helps to increase our knowledge of Notre-Dame and to have a better knowledge of medieval construction techniques and development of cathedral builders' know-how. This scientific work has been made possible by the public establishment's decision to open the project widely to these research groups. It was not easy due to the site access restriction and security regulation, but we decided very early after the fire to take this unique opportunity to learn more about the cathedral. And this support took 2 different forms. Firstly, applied research, which is directly useful to the project, which led the public establishment to encourage and co-finance studies. For example, we launched a national survey aiming to characterize and to identify the best stone for the restoration project with the help of public laboratory and private structures. Another example, we built an agreement with the University of Bordeaux in order to realize a study about the structure of the vault before and after the fire, as well as before and after the restorations. On the other hand, we facilitate scientific research that is not directly linked to the current work, but which increases our knowledge of the cathedral, its history, particularly the construction techniques, and the project offers a rare opportunity to explore in detail parts that are not normally visible or accessible. And to finish this introduction word, I believe that this collaboration between restoration projects and scientific research is unique. Its interest and importance have been proven, and now we can only hope that this is just the beginning for other projects, and it may be, and I hope so, one of the legacy of the restoration of Notre-Dame. Thank you.
Thank you, Ludovic. Following Ludovic, we have Martine Regert, who is a research director at Sierra Neras, together with Philippe Dillman, Pascal Liévaux, and Aline Magnon. She coordinates the Notre-Dame Scientific Action for CNRS and the Ministry of Culture. They are all together the guest editors of this special issue. And as Ludovic said, there was this strict relation between restoration and scientific work, analysis, and on Notre-Dame. And Martine will talk us about this, the Notre-Dame Scientific Work Site, an extraordinary interdisciplinary adventure. Please, Martine.
Thank you very much for this introduction. I just try to share my screen, and I'm not sure. Can you see my PowerPoint?
Yes.
Okay, because I cannot see me. Okay, so everything is okay for everyone. You can hear me, and you can see my screen. Okay, that's perfect. So thanks a lot for organizing this event. I will try to summarize some of the most important results obtained during this scientific adventure. So I didn't know how long I would talk. So if I'm too long, just do not hesitate to tell me and I will summarize what I want to say. So dear all, good morning, everybody. On behalf of the scientific coordination team, I will now endeavor to provide a synthesis of the most significant advances, well, some of the most significant advances in a few minutes in research carried out since 2019. One must note that despite its global reputation, Notre-Dame de Paris was a cathedral about which very little was known from a scientific point of view until recently, especially in terms of its material aspects. And this is probably due to the high number of visitors, with an estimated 13 million visitors a year, which prevailed any in-depth and systematic study of the monument. So I've changed the slide. Is it okay? Do you see the new slide?
Yes, we do.
Okay, thank you. With the fire at Notre-Dame de Paris on the 15th of April 2019, that you can see here on the left side of the slide, and the impressive restoration work that quickly followed the tragedy. You see the result here on the right that I photographed at the beginning of last June. It is, to our knowledge, the first time in the world that so many scientific forces, so many different and complementary disciplines have come together to study an heritage monument, and this largely, as it was said before, largely supported and funded by two institutions, the CNRS on one hand and the French Ministry of Culture on the other hand. This institutional impetus for public research is part of the emotion illustrated here in the middle of the slide that gripped France and all the world following the catastrophic damage of an emblematic World Heritage monument. This is here, the inside of the cathedral just after the fire. So you can see a jumble of various debris. But in fact, this debris, this these remains are not debris, they are heritage remains that contain an incredible wide range of information on their origin, their alteration over time, the techniques of construction, and also climatic and environmental evolution, and so on. It was thus necessary to correct, to risk, to preserve, to observe, to sample, to analyze these remains and this represented a huge and hard part of the work that was largely done by the researchers of the Laboratoire de Recherche des Monuments Historiques, so it's research laboratory for heritage monuments located near Paris. About this adventure, this wonderful human adventure of the first moments for saving material remains, you can read the paper of Dorothée Charroux-Derieux and co-author, From Debris to Remains, an experimental protocol under emergency conditions, in the special issue of the Journal of Cultural Heritage. In addition to this material heritage of stone, metal, stained glass, and wood, the cathedral has also been the subject of research into the intangible, the immaterial heritage, with questions related to the acoustics of the monument, its evolution over time, and the study and reconstruction of past soundscapes. The unprecedented emotion caused by the burning of the cathedral was proof of the great attachment to this monument all over the world. And this emotion is currently being studied by the anthropologists. It is indeed a question of how a specific heritage can be so universally shared as the Paris Cathedral. Moreover, in the context of restoration, which distances the monument from its user in an unusual way, the current research aims to understand what happens to this ring as revealed by the disaster. Last, the post-fire cathedral provided a unique platform for multidisciplinary studies and digital data analysis. A large-scale collaboration is currently underway to manage, analyze the extensive data generated by the restoration of the cathedral and by the scientific team. The work of digital data, and this part of the work is managed by Livio De Luca, is crucial to understanding complex multidisciplinary studies, especially in the field of cultural heritage. Last, the post-fire cathedral, developing such research during the restoration process presented a number of challenges that were also discussed just before by Ludovic Lebeau. The activities of different institutions, professions, and practices, there are very different ways of working on this site, had to be coordinated, taking into account the security constraints, but also the time constraints and the different objectives of the actors. So synergy between the different actions and institutions was essential to develop research and restoration in tandem. This synergy was of course effective between the CNRS and the Ministry of Culture, but the collaboration with the organization in charge of the restoration and conservation of the cathedral was also a key point for success. And the access of the cathedral to the cathedral, even if it was quite difficult to the complexity of the site and of the operations of restoration, was very welcome by the researchers that could go in the cathedral, observe different materials, make their correct the samples, and so on. So this was a really strong and effective and efficient collaboration, and I want really to insist on this. The INRAP was also part of the adventure. INRAP is the National Institute for Preventive Archaeological Research, and they did wonderful discoveries that I don't have time to detail here, but it was an important part also of the adventure. And there were I cannot cite everyone, but there were other research institutions, and of course, university was also an important, were also important actors of the collaborations and of the work. So you can see here that the scientific field was organized into 9 research groups, focusing on wood carpentry, on metals, on stones, on stained glasses, on monumental decor, structures, digital information, acoustics, and also emotions and mobilization, anthropology of emotions and mobilizations. After between 4 and 5 years of work, these groups have produced results that have shed light on various facets of the cathedral's history. And this information was recently presented and discussed at a meeting held in Paris at the end of April on birth. So sorry, it's in French, but the title was Birth and Rebirth of a Cathedral, Notre-Dame de Paris, under the Eyes of the Scientists. And you can see here, we just had the information yesterday evening that this event is now available online. And so you can assist to the meeting online and to the discussion and the debate and so on. Of course, in a few minutes, I could not talk of everything, but I will try to show you how the results of different working groups now converge to highlight some specific points of the cathedral, specific aspects of the cathedrals. I will first talk about the chronological aspects. Then I will deal with the supply of the different materials of the cathedral. And then I will turn to a subject that was not expected, perhaps, on such a cultural heritage subject. It's a case of information that we can gain from biological materials on environmental and climatic data. So I will highlight these 3 points in my presentation. Many new elements make it possible to precise the chronology of the cathedral, and it is now possible to reconstruct it with an unprecedented degree of precision. First, the wood of the frame with the annual rings of the wood that represent a real time machine allows to establish the phasing of the construction. The phasing places the construction of the original core here around 1185. Then the nave framework was established in 1214, and the core was reconstructed around 1226, and then some phases of reparation were observed for the 18th century. In addition, of course, to the big restoration of Ratio and Viollet-le-Duc that was held during the 19th century. The study of stones also provided some chronological evidence, and the lapidary marks reveal a north-south organization of the cathedral construction. And putting together this data, those coming from the stones and those coming from the wood, it was shown that the construction of the nave masonry base took place from the east to the west. Yeah, that's right. While the nave framework construction took place from the west to the east. The study of iron armatures or reinforcements used in the construction of the cathedrals also offers a glimpse into the innovation that took place on this building site in the mid-12th century, adapting metal to create a novel architecture. Radiocarbon dating were carried out on the carved areas that you can see here of some iron armatures, and they reveal that Notre-Dame is the first non-Gothic cathedrals where iron was massively used as a proper construction material to bind stones together in the entire construction, and this leads to a better understanding of the master mason thinking. Even if research is still underway to establish a detailed chronology of the cathedral constructions, we can already see that the data obtained on the various materials provide information on the dates and phases of construction, of course, but also on the spatial organization of the site. Other series of wooden and metal elements are still being dated, and the study of the stained glass and monument decor that I don't have time to detail here will also complete this chronological overview. Research into the origins of the cathedral materials sheds light on other aspects of the site, in particular the supply networks that were necessary to construct the cathedral, and we can also reach some economic organization, some information on economic organization. Concerning the iron metal, at least 6 different provenances were identified thanks to trace element analysis, and no predominant iron source seems to prevail. This feature is very specific to Notre-Dame compared to other cathedrals. So we can also replace the data obtained on this particular cathedral in the framework of the other monumental buildings that were constructed during the Middle Ages. It has also been possible to show how the sources of supply have evolved over time, have changed over time. And even if the sources have yet to be found, so you see that there are still many things to do, the analysis clearly shows that they were not local and that iron was sourced from outside of the region, which is a very, very new and important and interesting result. For the stones, their geological identification was carried out, and it could confirm what was already known, that the stones were coming from local sources. Finally, we have hope to establish the origin of the wood, of the oak wood that were used, and the working group on wood and carpentry is now building a dendro provenance database to try to trace the forest from which the wood were obtained. So you could see if you go to have a look at the meeting that was held recently in Paris, that it seems to be now possible to trace the exact forest from which the wood are coming. So this is also, it was a very challenging task with the isotopic data to obtain this result, and this is also a new result of the scientific field. The study of provenance is not the only facet of the information that can be gleaned from wood. That wood is just a wonderful material because it is a biological material, and it bears information on both the environmental and climatic data, but also on the know-how of the artisans, of the craftsmen and women. Sorry, I'm a bit lost. I'm on 8A. Yeah, okay. Indeed, the wood in the history of the cathedral represents memories of the forest of oaks grown since the Middle Ages in the Paris basin, and in particular, the isotopic composition of the wood reveals past climates and can be considered as a clock of the past. The study of wood also provides environmental and climatic data, as I already said, by combining information on the shape of the annual growth rings on their chemical composition. It is possible to determine the size and age of trees, the density of forest stands, the type of silviculture, and information on the climate and its evolution over time. Furthermore, traces on the wood are also a source of information about how it was transported, as this hole here that show that some wood were arrived by rock driving on the river, on the Seine River. So I hope I have not been too long. This is my last slide. Just to tell you a few words of the special issue of the Journal of Cultural Heritage devoted to the research on the cathedrals of Paris. This special issue, I hope this special issue reflects several aspects of the research. First of all, it deals with the exceptional scientific and human adventure. And this is usually not present in the publications because we focus on why we did the things, how we did the things, the research, and what results we obtain. But I think this adventure was more than that. And there were really new collaborations, new practices that were built during this experience, and I think this special issue gives evidence for all this evolution of our practices also. Of course, it deals with the interdisciplinary dynamic of the project. This is a point that is very important for the Journal of Cultural Heritage, as mentioned before, and I think we obtain a lot of data between different disciplines and with very integrated approaches. Of course, it deals with the work of the research groups and with the results already obtained on a wide range of topics on both the materiality and the intangible aspects of the cathedral. Therefore, the special issue constitutes an exceptional, is an amazing collection of research on the monument from its physical characteristics to its digital twin, and it covers all aspects of the work carried out from acoustics and sound space to the emotional impact passing through the history of the materials, and of course the study of environmental and climatic evolution. Oh, sorry. So I thank you very much for your attention. I hope everything was clear and give you the opportunity to go to have a look of the papers that were published and to the meeting that is now online. And I will now, of course, hand over to my colleagues from the different research groups who will give you a more detailed presentation of the research carried out in certain working groups, and you will have better insights or more precise insight on some of the results obtained. And I thank you very much for your attention.
Sorry, Martine, it would be nice if you could introduce briefly each speaker.
Okay, so the next speaker, if I don't make mistake, is Olivier Girard-Clos, who is working at the CNRS at the laboratory named Chrono Environment, which is in Besançon. And he will talk about post-fire studies of Notre-Dame's framework, so about the wood and the carpentry, historical and environmental wood memory of the medieval period between the 11th and the 13th centuries. So it's to you, Olivier.
Here is a good one. It's okay. Do you see my slide? I think you have not been. Now it's okay?
It's okay.
Do you hear me clearly? Oh. Maybe not. Do you hear me? I hope it's okay. So first, I would like to thank to give me the opportunity to present our result here. I will say something similar from Martine, but in more detail, as she said at the end. The The Notre-Dame de Paris wooden oak frames is one of the greatest masterpieces of the Gothic carpentry in France. It was constructed between 12th and 13th centuries at a time of profound environmental and societal changes, climate optimum, strong demographic and economic growth, which created the significant pressure on available forest resources, one of the key economic drivers of medieval society. The objective of the Wood and Carpentry Working Group is to recover the maximum of information necessary to produce a multidisciplinary study of the disappeared wood frame and on the wooden beams used to construct. We obtain a funding from the INR, the project Quasimodo, doing this. These objectives are covered in detail in the paper, in the special volume written by Alexa Dufresne. As you've already noticed, I'm not Alexa Dufresne, but I will try to give you an overview of the work of the group with emphasis on dendrochronology, which is my specialty. Before the fire, Paris Cathedral was relatively inaccessible to scientists for a number of reasons, and the framework is not exception in this rule. The first drawing comes from Viollet-le-Duc himself before restoration in his dictionary. Dendrochronologists first looked for material to build dating references, the so-called master curves. Notre-Dame's framework design was included in a typology from northern France and Belgium, which clearly shows that innovation in frameworks was very important between 1150 and 1240. And finally, the architects Fromont and Transo were the first to carry out systematic surveys of all trusses and timbers. But the study remained separate, and no interdisciplinary approach was put in place before the fire. In particular, the result of dendro dating were never cross-referenced with the surveys. I can show you some photographs taken before the fire, and observed by layman eyes, this framework came as a forest, because of the large number of beams required for its installation. A few days after the fire, my colleagues, who did the first dendrochronological dating, were among a very large number of scientists who report that the remains of the fire contains information of great value for our knowledge of the building, and more broadly, of its construction period. This is particularly true for the wooden remains that form the frameworks of the building, but which are also recorders of their environment. In fact, the trees that deliver the wood record in their growth the climate, the silviculture, and the harvest pressure. You can still see on these pictures that they provide an optimistic snapshot of the wood potential. We have finally had to analyze much more restrictive examples, even though they are still very rich in information, as in this case of estimating the diameter of the log needed to shape the tie beams. The project of Notre-Dame oak wood frame study proposed 4 lines of research. The first is to study the timber and destroy frameworks. The second consists of characterizing the forest stand exploited. And the third purpose is to define the climatic and socio-economic context. Investigation for the fourth objective are on the hydromechanical properties of oak beams to better understand the choice of use of oak in Middle Age. To achieve this objective, the Wood Working Group brings together 70 people from a wide range of disciplines, from archaeologists to specialists in wood as a material. In the special volume, you will find papers based on first results for 3 of these objectives. For example, my colleagues present their methodology and protocol to past climate and yearly sea footing variability reconstructions. But finally, since the submission of articles from first results, I would like to share with you the progress made by the interdisciplinary work. We were able to collectively discuss the climatic context in the Middle Ages and develop results on the state and the dynamic of forest exploitation. These were achieved by characterizing the trees used in the frame and starting annual resolution analysis after dendrochronological dating wood, but also by exploiting historical sources and other environmental markers such as pollen and charcoal from archaeological and natural sites around Paris and Notre-Dame. So more inside the woods, I'd like to say the achievement of the objective that puts georeferencing first would not have been possible in the same way without the close relationship with the digital working group, which has brought real synergy to our research work. Kevin Jacot works on the carpentry was decisive. I cannot tell you the detail, but he was able to use laser grammatic point cloud and Shire style line drawing to build a three-dimensional model of the structure. We have combined the three-dimensional representations with a control vocabulary for naming elements. It's well known to observers, but also to carpenters, that naming beams in a space nomenclature makes them easy to locate. We were also able to relocate the position of all dendrochronology cores in the model and reanalyze the dating data. Finally, an important reason of the special volume paper is to produce the first link between dendrochronological dates and surveys. This comparison was carried out by Frédéric Kepo on the basis of visual observations made from a large number of photographs. Since then, we have analyzed a fairly large number of remains, and major questions of interpretations have arisen concerning the construction chronology of the core. It's essential to update these results, which is rather useful after further analysis. The three-dimensional view of the roof structure can be compared with post-fire data, in this case directly on the extruder of the boats. And our daily work consists of making progress in the study of both directly in the warehouse that the public establishment for the restoration has set aside for storage of the materials. We now have an accurate knowledge of between a third and a half of the total number of wooden items in our study is based on over 300 precisely described woods. The most significant woods are photogrammatically described. Since January 2022, 160 woods have been modeled using protocols constantly improved by the help of digital group. Digitalizations enables line drawing to be produced in selected direction, drawing making available information on paper, and additional observations such as location of cuts, which are then studied in dendrochronology and wood mechanics or chemistry. Digital models of the object are compared with various data sources in an attempt to relocate the remains within the framework before the fire. Finally, the agreement of the relocation is also observed by the three-dimensional model of the frame. Digital modeling of the remains also make it possible to understand detail of the frameworks, such as these particular mortise and tunneling joints, which was not visible before. Once all the dimensional and archaeological information has been recorded. Several slices for collection and analysis are sampled in a workshop dedicated. We had to optimize the use of the tools for finish the slice to observe the dwarf rings in the wood and charcoal in the shortest times possible. Finally, slices have been sampled for more than 400 wooded items. Drawings have been analyzed on around 300, and more than 175 have been dendrochronology dated. This quantity is beginning to show that we have seized the opportunity unfortunately offered by the fire to work on a large number of wood from this masterpiece of frameworks. Consequently, the chronological serialization of oak failings was based on 40 tree-ring width theory at the time of the article for the special volume from Cords, and whereas today more than 200 are available. Most of the work that remains to be done is to connect the different information derived from analysis and descriptions, dimensional positioning in the roof, and archaeological facts in very different levels. All I can say here on the result is that the core frame was first built shortly after 1185 and rebuilt using most of the originate wood around 1213, while the nave's framework was built around 1214, probably using wood from different origins and modified at least twice around 1230 and finally around 1290. In comparison, you can see it's not evidently similar from the journal version. I thank you for your attention, and I thank also all the members of the groups with this last slide. Thank you very much.
I didn't present the working groups before, so you understood that Olivier Gérard-Claude was part of the working group on the wood, and then Frédéric will talk after on the questions of the structure in collaborations with other working groups, and Brian Katz is part of the acoustics working group. He is working at the CNRS too, and he will talk about study and analysis of the sound environment. So it's a subject of actuality of the Notre-Dame construction site between the 12th and the 18th centuries.
Okay, let me quickly share. Make some noise if that doesn't work, otherwise I'll just start going. So I'm kind of going to present an overview of some of the work that we've done on the acoustics, the soundscapes, and the intangible heritage of Notre-Dame in the context of the working group. So the first question is kind of where do we start studying when we look at the acoustics? So we can look at acoustic measurements to kind of quantify the state of acoustics at the moment. But we can also do modeling and numerical simulations to look at the impact of different specifics. We can calibrate those models with the numerical models to get better results. And one of the powers of the computer simulations is that they're modifiable. So once we have a model that's calibrated, a digital twin of the acoustics, for example, of Notre-Dame before the fire, we're able to retro modify and study different times in history of the cathedral. And we can see how the cathedral has evolved over centuries in terms of both architecture, but we also know in terms of decorations and furnishings, changes in style of events and how it was used. And we're interested in looking at how the acoustics interplay with these different evolutions with a certain focus on musicology and how music evolved around Notre-Dame and within Notre-Dame. So kind of the real fundamental questions we have when we start using digital reconstructions is, can we trust the acoustic fidelity of the reconstruction? So if I do a virtual measurement in the computer model, do I measure the same thing that I get in the real model? So that's kind of our first level of validation. Then we can look at, do we trust the auditory fidelity if we start doing virtual reconstructions? So do I hear the same thing in the virtual model as I would in the real model? And then the final stage is, can I create a convincing immersive environment where I actually feel like I'm in the space? So do I react the same way in the virtual reality version, which is kind of our measure of ecological validity? So a couple of studies that we've done focusing on that are looking at singing in the different acoustics of Notre-Dame over history. So we developed interactive singing model. So we can have 4 singers that are singing together in a sound-free space, but at the same time, they're actually singing in the acoustics of Notre-Dame that we can change dynamically. And we're looking at the analysis of their behavior, of their performance style with questionnaires to kind of look at, is the evolution, say, of the school of Notre-Dame's polyphonic music linked, or does it work better in certain acoustics and certain dates than in other dates? And we spent a lot of time trying to recreate the realistic version of this. And we're analyzing that now, but let me just play just a quick excerpt of one of the recordings. So the key is what you're hearing is kind of the acoustics of what they're hearing with the added reverb of Notre-Dame. And as these singers had experience previously singing in Notre-Dame, one of the best feedbacks we had was saying that it was just as hard and they had the same kind of difficulty singing in the virtual Notre-Dame as in the real Notre-Dame. If we look at the second aspect, major aspect that we look at in the acoustics group, it's looking at the soundscape archaeology, so kind of going beyond just the architecture of the space, looking at the history, historical aspects of the soundscape, trying to reconstruct, for example, the work site of Notre-Dame at different periods, going through the sound archives of various elements and kind of the nature of focusing here on the construction workers and looking at how artisans have used sound over history while they're building, and also documenting what is happening on the current construction site for archival purposes to better understand the construction site activities of today. So the basic procedures that we look at are, we go into any kind of documentation on how things sounded, both in written and visual documents when we're looking at something before the time of recordings, any kind of documentary evidence, discussions of what things sounded like, how information has been passed on over time from word of mouth in terms of artisans. And then we try and identify and capture corresponding sonic elements today that would represent what is happening in the past. And then we propose plausible virtual reconstructions by assembling all of those elements together into a virtual environment. So these can be presented over headphones or over spatial loudspeaker arrays to kind of create multi-person environments. And there's kind of a number of examples that we have with some QR codes where you can listen to reconstructions of the construction site of Notre-Dame in the 12th century. So in this special issue, we kind of published 3 articles looking at the reconstruction of the sound environments, looking at voices of children in Notre-Dame, so looking at the children's choir and how it evolved in the Middle Ages and how it would compare to today. And then in collaboration with the Emotion and Mobilization Working Group, we kind of worked on an inquiry with a number of questionnaires and interviews into how kind of people remembered the acoustics of Notre-Dame before the fire, and how also that has evolved over quite the number of years by interviewing people that have been involved in Notre-Dame for quite a number of decades. And then I kind of want to point to kind of another aspect, which is how we look at research communication of a project of this nature, like Notre-Dame. So we know that conferences can be engaging, kind of like what we're doing here, but they're limited in public attendance and also in technical capabilities for spatial audio. So what we're doing is really creating these immersive environments. And as we see with the system today, we can only present mono audio. So you can't create the 3D immersive reconstructions over headphones, and you definitely can't create the multi-loudspeaker kind of systems. Journal publications are good for scientific results, but again, are very directed to specialized audience and not good with communicating with the public. So we kind of looked at how to explore new possibilities for sharing our research with the general public. And touching on a couple of those, the idea is really to go from research to outreach. So the research team identified a number of key scientific results that we want to communicate. And then we worked with content creators to develop scenarios or concepts, giving them as much artistic freedom as possible under the constraints of actually presenting those results either directly or indirectly. It also gives us the opportunity to kind of present behind the scenes information to people who want more information, to see how those the things have been created and what the articles behind those are. It gives links to supporting more research for those who are interested. The goal is to be targeting a large audience. So even though we're in France, everything that we're doing, it should at least be in French and in English and should be freely available. So the first big project that we did was a year ago, which was a historically inspired radio fiction, looking at Victor Hugo, who's having writer's block and is visited by a muse who kind of transports him into different periods of history. And then we can use our acoustic recreations and discussions that he has to kind of highlight events coming out of the research. This is all a 3D reconstruction over headphones that takes about an hour, done out of 4 episodes, done in partnership with Audible Research and Development, and that's freely available in French and in English. And then the second is a smartphone audio guide, which is more of a museum style edutainment system, where we have a real persona of Notre-Dame who has lost her memory after a traumatic event and is kind of helping the listener understand the history of Notre-Dame, both sonic and otherwise. Can be freely downloaded onto any smartphone. And it can be used either on site with GPS or remotely without GPS, and that's available in English, French, and Spanish. And the project that we're currently working on now is more looking at the musicological aspects and looking at producing a concert documentary, looking at how music has evolved over 8 centuries in Notre-Dame, how the acoustic evolutions in Notre-Dame in terms of architecture and decoration follow kind of those acoustic elements, and to reconstruct musical pieces as they're played in the historic acoustic conditions of the period. And this will present kind of an immersive concert going experience interlaced with documentary evidence. And we're looking at that coming out in French and English and probably some other languages with subtitles. And we're aiming for the end of this year to have that. Here's just a quick list of a lot of the people involved in all the work that we've presented, thanking all the musicians and the cathedral and the UPA for access to Notre-Dame. And here's a number of links if you want to listen to more of these things and get access to all the examples that we've been doing. And I think I can stop there and wait if anybody has questions or go on, and we can do questions at the end. I didn't quite, I forgot how questions were working.
The questions will be at the end.
Okay, then I'm more or less done then now.
Thank you very much, Brian. So we are, can we try with you now, Frédéric? Could you change of place?
Perfect. Okay, so I will restart. Sorry for this. Sorry. Okay. I will share my screen. Yeah. Okay. So I was talking about this, but okay, I will skip now. So what you have to, what we did. So the first part of the work, on the main part of the work currently was done on the structure, so more on the masonry part of the cathedral. And what we were interested in assess the structure, particularly the vaults. Okay. In fact, the people doing computation, they use three kind of software or methodologies, let's say. So in fact, some of them are considering that the structure is made of blocks like these. Okay, so we have a kind of block by block or block-based models. So in our case, in Montpellier, we are developing discrete element method approaches, and we try to use these approaches. So we consider that all the stone blocks are independent, and that between the blocks you have kind of contact with a particular contact law, which is a friction cohesive zone model, which mimics the behavior of the mortar and the interface of the mortar and the stone. So this is one approach. So this approach is quite expensive from a computational point of view, but in fact it allows you to, for example, to simulate the total collapse of the building if you want. Another strategy was to use finite element, which is more classical, and to use a kind of textured mesh. So let's say that in your mesh you have mesh for a part of the mesh considering the blocks and a part of the mesh considering the joint. Okay, so you do the distinction of both, and also you have this finite element for the blocks, and you have joint element which are particular. And the constitutive model we used for this was more Coulomb law, so it helps to describe friction and cohesion between blocks. So these are the block-based methods, and after that we have some continuous approaches. Also in that case, we consider that we are not modeling the geometry of the blocks. We consider something which is homogeneous, but we put all the information concerning the masonry behavior in the constitutive model. Okay, so here you have something which is able to take into account a different behavior when you do traction, shear, compression, and things like that. You are able to have also crushing of the material and so on and so on. So it's quite complicated. So it's simpler from a geometrical modeling point of view, but you need to find a lot of parameters in order to use this kind of models. Okay, so in Montpellier we use this discrete element. In Paris, they use these finite elements, and in Toulouse they are using this also this finite elements model. Also after that, what we have to do is to build a geometrical model. Also this was complicated because we don't have anything when we start to study the cathedral. So we start from the point cloud made by Andrew Talon, and using this, we use working with people from the Livio's laboratory and also people from a small company, Stono. We made a model. Okay, so depending on what we need, we made either a continuous model. Also, let's say you have a continuous part for the vaults and a continuous part for the block dress, or we made a block by block description like this, also which is more complicated to describe the structure. Okay, also it was an iterative process, but at the end we did some computation with simple model, and after that we enrich the model. One other problem for us was the mechanical properties of the stone. Also, in the past, we did a lot of measurement in the labs. Okay, so we have measurement to be able to have for example, the traction behavior between two blocks with a mortar joint. So we have this kind of law. So we develop a lot of things around that. Also, we did also some structure test on some structures. Okay, for example, this compression, shear of walls and things like that. Also, so at the beginning, when we didn't add any information on the material property, we try to use this as equivalent material, okay? And progressively, we were able to do some measure in the cathedral. So, for example, using sound velocity and using some kind of correlation between this sound velocity and the mechanical properties. And after that, iteratively, once more, we update our model to have more relevant solutions. Okay, so okay, I go on. After that, if you have any question, I can answer. Okay, so what I will show you, the results I will show you today is the first, how was the original structure working, what is some impact of the fire. So I won't show a lot of things, but I should show some results, and the work in progress we have currently. Okay, so first of all, okay, we were not able to compute the entire cathedral. It's too huge. Okay, so we just use consider a slice of the cathedral. Okay, and so it was a 3D model, and in that slice we have a vault, we have walls, we have piers, and we have a buttress. Okay, and the idea, since the idea was to see the influence of the fire on the vault, what we did is that we separate the sound part, okay, and the damaged part, okay. So it means that we use a kind of splitting, and the idea was to say, okay, we will compute the behavior of this green part, applying a force or a displacement. So we want to obtain this force displacement relationship. Okay, so we do a computation considering this, and we obtain this green curve here. Okay, and after that we did taking into account this behavior here. So no, sorry. After that we did exactly the same for the vault. Okay, and after that we check what we are looking for the crossing of these two parts, okay, which is the working point. So this is the point where you have your equilibrium, okay. So we tried two way of cutting the structure, but it's not important in here. Okay, so and what we did, for example, is that if we consider just the buttress here, what you see is that, okay, depending on the direction of the load, what you observe is that, okay, for example, here, if you have an active thrust, okay, what you see is that, in fact, you have a wedge here, so it's a flexion behavior, okay, and you see that here you have the response of the structure, and you see the difference of the three models. So it's quite similar. So these are not the last results, but in a way for us it was satisfactory because we recover the same behavior. And if you consider the passive thrust, okay, in that case you have this kind of behavior also. Okay, and if now you have a look to the non-linearities in the structure, so let's say the damage, the opening of the joints and things like that, you observe that, okay, we obtain damages almost located at the same place, okay, and so it depends if you are, so the damages, if you are in a active state or passive state, it's not the same pattern of fractures, but okay, you see that in the case of passive state, you have the fracture in the flying part, flying buttress, and if it's an active state, you have the main damage in the pier, in the buttress. Okay, but the only comment we can do is that, okay, even if we don't have any information on the position of the block with this finite element method, we are still able to capture the damage. Okay, so here you have, this is more meaningful. You see that the fracture is following the joints, but anyway we see that the mechanical load, okay, it is triggering the damage at the same place. It's an important conclusion. Okay, if now we consider the vault, we do the same. So in the 6-part vault, you have strong buttress and weak buttress. So we were interested in applying finding this kind of constitutive or behavior law of the vault, applying a force either on a weak buttress or a strong buttress. So you see that, okay, strong buttress is behaving like that. So once more, we have quite similar results. And for the weak buttress, okay, we have quite similar results also. And we have, if we have a look to the damages in the structure, what we see is that, okay, once more, the orientation, in fact, the triggering also of the damage is the same. We have some paths is a little bit different, but it's quite similar anyway. Okay. So now, if we want to take into account the impact of the fire, so we have, okay, deep impact like the collapse of the web, but we also have some impact due to the material change. Okay, so we were more interested in this effect of the change in the material, of the property of the materials. What was observed doing some comparison of the point clouds before the fire and after the fire is that part of the structure has moved. Also, what you see, for example, in this on this vault is that, okay, the center of the vault is, the displacement is increasing. Okay, so it's plus 2 centimeters, and here it's decreasing. Okay, on the web, so it's minus 5 centimeters. Okay, so the idea was, okay, are we able to recover this kind of phenomenon? Another thing was that we observe a lot of fractures, so we don't know if this fracture were there before the fire or if it's a consequence of the fire. But anyway, also we observe some fracture in the columns between the rib and the web, in the web, and so on and so on. Okay, and probably we won't be able to observe all the fractures. So what we did is that we take the material and the geometry, as I showed you before. We create this model. What we need to add is some information concerning the temperature of the stone. So we did some experiment in the lab, and we observed that for limestone, the color of the limestone is changing with the temperature. So we did a kind of map between this color we can measure on the structure and the temperature we apply on the stone. Okay, also using this, we define a scenario concerning the temperature due to the fire on the stone. Okay, and we start doing some computation. Okay, and at the end, what we want to do is to compare the displacement and the fracture in our model. So this is, for example, the damage computed using the software developed in the model developed in Toulouse. Okay. And after that, okay, we can try to validate the hypothesis, and eventually we try to do some correction of the model. Okay. So what is interesting first is that if we consider the buttress, the effect of the fire, so due to the dilatancy, the dilation of the vault, you push on the buttress. Okay, also you increase the force applied on the buttress. And you see that, in fact, these buttresses are well designed because they allow you to support an increase of the force. Okay, and you see that we estimate that we have 15 tons instead of 77.5 tons just with self weight. So it means that you see that, yeah, okay, it's still stable, and it might be possible to resist to an higher load. Okay, so this was a first interesting thing. After that, concerning this motion of the vaults and so on, in fact, we recover something which is similar. Let's say that you have a positive vertical displacement at the center also, and after that you have some part with a negative displacement, and they are in the same order of magnitude. Okay, and we recover this X shape. Okay. After that, concerning the fractures, in fact, okay, what you see is that the numerical model gives you a lot of information, but you can try to identify the main fractures, and you can try to compare them with what you observe in situ. Okay, so here you see that what you observe is that the pattern is symmetric. due to the way we compute things. But anyway, we recover something which seems quite similar. Okay, so now I will finish. So this was a short presentation of all the things we did. So if you have questions or if you are interested in, please contact us and we can give you some papers and things like that. What we are doing now is just to see the influence of the wood and the steel framework. Also, let's say that okay, Olivier showed you the work they did on the frame. So now we took this information on all the naming of the parts and the mechanical parameters, trying to also have information on the joints between the different parts and things like that. So we are doing things around that, and we try to couple this model we did with the masonry part, and we try also to add all this steel staple you have in the structure, which was for us something we didn't know at the beginning. Okay, also I will finish now. Thank you for your attention.
Thank you, Frédéric. So we are now going to listen to Adrien Delépine, who is working at the CNRS Heritage Unit, and who is going to talk about the research on anthropology of emotions and mobilizations after the fire of Notre-Dame de Paris.
Well, thank you. I hope you're hearing me well.
Yeah, it's okay for me.
Yeah, perfect. So first of all, I would like to apologize for Claudie was now couldn't be there today at this event, but I'll do my best to embody her demonstration. I'm going to share my PowerPoint just a few minutes later, but I have some pictures to show you. So first of all, in our societies caught up in change and globalization, it is commonplace to say that heritage has become a general remedy for impermanence of things, a refuge value supposed to guarantee continuity with the past while projecting us into the future through the legacy of which we are the temporary custodians. Heritage has become a new order of time, as well as a vast device for producing paradoxes, as a place of celebration of an entre-soi that can be shared with others. Its recognition would guarantee both the right to history and the possibility of facing the future through the capacity to enter on an equal footing into the great dialogue of cultures orchestrated by UNESCO as the means of reducing the fractures and tensions of our contemporary world. Sorry. In 2003, the Convention of the Safeguarding of the Intangible Cultural Heritage completed the long evolution towards a multicultural World Heritage List, proposing a new balance between the countries of the North and the South, breaking with the Western tradition of an essentially built and monumental heritage, and advocating to the growing recognition of the expertise of communities in the designation of what constitutes heritage. The latter seems to have become, instead of development, once a universal promise of happiness and peace, the phantasmatic place of all reparation. In this context, heritage is therefore subject to a complex political and diplomatic stakes, going far beyond historical or artistic considerations, stakes to which heritage professionals are sometimes at a loss. Heritage is not only a collection of cultural assets which materially must be preserved, it is also a symbolic issue, the vision a people has of itself and its place in the world. That's why anthropologists and social scientists are present alongside specialists in stone, wood, glass, and other materials from Notre-Dame de Paris, who contribute their expertise to the scientific worksites launched by the CNRS and the Ministry of Culture following the cathedral's fire. To briefly summarize our working group's principles and questions, our approach consisted of jointly address the material and immaterial dimensions of the building its materiality and its sacredness, examining how the fire and the restoration work, far from disqualifying the monument or relativizing its heritage dimension, have, on the contrary, reinforced its exceptionality and patrimoniality, showing that the restoration of the cathedral structure is also about different registers of sacredness carried by different collectives, religious or cultic sacredness, heritage or cultural sacredness, and political sacredness. Three dimensions that coexist in the restricted space of the building, alternating, combining, or coming into conflict. A recent discussion between the French president and the church concerning the cathedral's reopening in December about the ceremonies of the reopening is highly symbolic of a recurring double questioning: who owns the cathedral and who and what can express themselves there? Answering this ultimate question, what is repaired or intended to be repaired, while restoring and reconstructing the spire, the frameworks, or the vaults of Notre-Dame de Paris? In this regard, various fields and approaches have been implemented, which the special issue of the Journal of Cultural Heritage details comprehensively. Three of them have been particularly developed, and this is when I'm going to share some pictures. So I think you are seeing my screen.
Yes, we are.
Great. So the first involves observing and analyzing the actions and words of the different collectives working on the site to understand how the exceptional nature of the place has influenced the treatment of materials on the site, to attempt to identify the registers of sacrality employed, whether secular or religious. This includes the debris elevated to the status of remains, which have been sorted, classified, and preserved while being the object of public appropriation desires, considering them as quasi-relics. Also, the stone and the wood structures intended for reconstruction, which treatment is marked by a form of exceptionality, aligning with the grandeur of their destination. The use and highlighting of exceptional skills play an important role in this metabolization by the monument of the new materials that comprise it. The second approach focuses more on narratives. These include individual accounts of the emotions felt during the fire and how personal biographies connected to the grand history of the monument, memories of the restoration site, both personal and collective, as an exceptional moment, a unique experience that is both exhilarating and exhausting. And also the mediations that tell the story of Notre-Dame multiplied since the site's closure, some of them constructing in words and images the epic of the restoration. This outgoing story of the site under construction must be put into a long-term perspective, from the hagiographic deeds of the Middle Ages to their secular transposition in the 19th century, when the exaltation of the nation replaces that of faith. The third approach comparatively examines the notion of heritage catastrophe, varying cases, countries, cultures, scales, and natures of the concerned heritage. The results, perfectly resonant with the case of Notre-Dame, show that heritage indeed constitutes a distinct symbolic class within the materials world of humans. Moreover, concerning monuments, catastrophe is far from leading to the annihilation of the heritage value of the destroyed asset, instead reactivates the entire range of process involved in constructing heritage values, thereby writing a new chapter in the history of the building. While in the context of the review, we have mainly focused on the coexistence of religious and cultural logics, I would like to conclude by returning to the political dimension of the restoration project. The fire at the cathedral occurred at a very specific moment in French political news. On the very evening when President Emmanuel Macron, at the end of the great national debate that had lasted several months, was supposed to provide the state's response to the Yellow Vest movement, les Gilets jaunes, for those who know. The fire disrupted all the planned organization, and the speech was ultimately cancelled so that the president could go and oversee the efforts of the fighters of the fire. In this particular social context, the emotion and the amazement at the sight of the flames devouring at high speed the roof of this emblematic monument of French history quickly gave way to controversies. While the political parties stand mostly united with the government, respecting the sacred union that tacitly forms in the face of every national disaster, divisions became glaringly evident on social media. While some people, all religions and political colors combined, share sadness, others give themselves over to a political reading of the events, suspecting President Macron of taking advantage of the fire to distract and bury social issues, the most radical ones going also so far as to accuse the government of having orchestrated the disaster to avoid responding to the demands of the French. Meanwhile, Emmanuel Macron's promises to rebuild the cathedral in 5 years, even more beautiful, and the announcement of an architectural competition to replace the spire that have disappeared in the fire, appear to be symptoms of presidential hubris and raise an outcry, while petitions are multiplying, calling for an identical reconstruction. Finally, in this context of social crisis and debate on inequalities, the announcement of the huge donation sums promised by the greatest French fortunes is also considered as a provocation and an indecent. Indeed, the 3 richest families alone invested in luxury industry pledged to pay €500 million even the following day of the fire. These millions of euros forestone indignant those who oppose them to the indifference that the great social or humanitarian causes arouse, and the contrast serves to question the moral hierarchy of capitalist societies. Far from uniting these people of builders described by Emmanuel Macron, the fire only feeds the mistrust of average French people towards their elites, be they political, economic, or intellectual. At the question of Notre-Dame, even goes so far as to divide the Yellow Vest movement itself, which was very heterogeneous in its composition, between those who consider the cathedral as a national symbol that must be raised at all costs, and those who question its importance. The Saturday demonstrations with the signs carrying various claims are good indicators of these dissensions. At the same time, on the provincial roundabouts that the Yellow Vests occupy, we see the appearance of ephemeral Notre-Dames being built with wooden pallets and salvaged material, where new forms of communalization are being experimented with and where new patrimonial models are perhaps trying to be invented. quickly raised by the authorities, these transitionary monuments allow the yellow vests to reverse the image of breakers applied to them and to claim to be the people of builders that Macron praised at Notre-Dame and scorns on the roundabouts. From then on, and very openly, the reconstruction of Notre-Dame de Paris became part of a political agenda that sometimes collided with the technical imperatives of the restoration project. Meeting the 5 years deadline imposed without consultation by presidential will became the evidence of the presidential ability to keep his promises. Everything became politically significant, whether it was the exceptional nature of the worksite, characterized by the complexity induced by the simultaneous presence on the monument of trades and that normally works sequentially, all the implementation of traditional know-how revisited by the demands of a timing characteristic of modernity and its tyranny of speed. The lots of the calls for tenders were divided in such a way as to allow the largest number of companies to respond, while great attention was also paid to their distribution across the country. Similarly, the oaks intended for the framework came from all regions of France, considerably complicating logistics, but embodying the idea that the cathedral represents the nation, its excellence, and its resilience. The whole work site finally became a symbol. Today, the bet seems to have been won. The 5-year deadline will be met, and while some on the project regret that the opportunity was not taken to give the trades and sometimes lost skills the long time of cathedral builders the time to reinvent themselves as well, nothing fundamental seems to have been sacrificed on the altar of speed, except for the human cost. We gave it our whole is a phrase often heard. Nevertheless, just as in 2019, the fire did not for a single moment erase the social fractures tearing the country apart. The restoration of Notre-Dame and the extraordinary work site that made it possible, while of interest to a majority of French people, do not change the political landscape. Notre-Dame remains a symbol, occupying a usual place of symbols that is of representation. And I thank you with these last words. Thank you for your attention.
Thank you very much, Adrien, for this presentation, which shows how cultural heritage deals with contemporary questions. And now, Livio, it's your turn. So Livio is CNRS researchers working at the MAP unit in Marseille, and he will talk about a digital ecosystem for the multidisciplinary study of Notre-Dame de Paris.
Okay, first of all, do you see my screen and do you hear me?
Yes, both are fine.
Great. Thank you very much for this presentation, Martin. Thank you all for the organization of this event. So after all this presentation, I think you can easily understand that the Notre-Dame project showcased very well how material objects and human sensibilities and multidisciplinary knowledge can co-produce new insights. So in the digital age, the challenge is to link the physical characteristics with this collective knowledge and to analyze the interactions. So the digital realm enables this by documenting and by studying how different disciplines like architecture, engineering, archaeology, physics, and chemistry tackle these common challenges. And our ERC-funded project, which is a part of the Digital Data Working Group until 2027, aims to build a new research matter and a new research field, we are creating like a digital ecosystem that combines the evolving representation of Notre-Dame Cathedral with the collection of the data and the knowledge, multidisciplinary knowledge generated around it. So our methodology consists of two main research phases. The first one focuses on creating some semantically rich data by documenting the journey from the researcher's questions to the data production and the knowledge creation and interpretation. This involves tracking each step in the process, such as the data collection, the element selection, the study of relevant features, the digital and the physical reconstruction of the arch, as an example. And this consists of adding information to the data that trace the data producer contributions to build this collective knowledge. And this integration forms like a semantic layer that represents the knowledge within the data. So the second phase focuses on analyzing the produced data by linking multiple representation of the same material object through the digital versions and through several temporal states of the cathedral. For example, a 3D model of a beam used for mechanical studies can be connected to the historical survey drawing and can be analyzed before and after the fire, including the wood provenance and dating as presented before. And this phase of our research aims to explore the intersections of several disciplinary perspectives by studying the relationships between the material and the knowledge objects. And so the digital dimension enables us to navigate through several dimensions of the form, so the shapes, the space, the time, and the knowledge perspectives. There'll be reaching several fields of knowledge. So these scientific and methodological challenges are discussed in the first of the four digital data articles into the special issue. So since 2019, our working group has been integrating a software platform based on web technologies to centralize, to enrich, and to spatialize heterogeneous data by federating various French and also a few of international research actors focused on heritage digitization. The goal was to integrate open and reusable software from different laboratories into a common ecosystem that manages the entire data cycle, that life cycle today. And this includes the data ingestion, the visualization in multiple dimensions on the web, in 2D, 4D, maybe also in 4 dimensions, and several stages of the semantic enrichment through the metadata schemas, the controlled vocabularies, and the semantic annotation. And this foundational work has facilitated the data circulation among stakeholders and enabled laboratories as well as the actors belonging to the restoration worksite to explore interoperability issues and enhance software functionalities for building like a unified framework. You can find the details of this platform in a dedicated article of the special issue. So, concerning our method of work, we collaborate closely with the data producers to define relationships between material objects, knowledge domains, research objectives and disciplinary fields within the data space. So our approach involves building a data corpus connected to its production context rather than archiving whole data in a flat way. So this includes restoration-related data, the architect's diagnosis, the data from various research working groups, and these methods maintains a dynamic and a context-rich database that supports interdisciplinary research and allow exploration from multiple angles, as you can see. So by linking data to its context, we ensure the generated knowledge is comprehensive and nuanced, reflecting the complexity of the Notre-Dame's restoration and the complexity of the multidisciplinary study context. To give an example, the timber frames. So on the screen, you can see the digital reconstruction that our working group created based on the data gathered about the state of the forest before the fire. So this reconstruction is connected to several other datasets, such as thousands of photographs and surveys from Montreal, which served as primary sources to the digital reconstruction. And it also linked to the survey of the charred timber remains recovered on the extradus of the vaults. But the same models, which has been provided to architects for the restoration project, is also used, as mentioned by Olivier, by the wood and carpentry working group to identify, to digitize elements that they are studying into the reservice. And the hypothetical reconstruction is employed to verify the potential location of elements within the original structure. So to confirm, to refute hypotheses about the remains identification and precisely locate the dendrochronological data. So you can easily see what is the cross-cutting role and position of all these interconnected data into the entire human adventure. Now, let's follow the path from the material objects to the multiple objects of knowledge. So the first challenge for us was the transition between the material object to the digital representation of it. And this involved not just to surveying, to digitize the cathedral, but creating a framework to integrate multiple scans and at various scales and temporal states. And an initial key contribution was establishing a robust alignment strategy for comparing all these different temporal states. And for instance, we provided a metric comparison of the vault's condition before and after the fire, aiding in studying the structural deformation. And additionally, we monitored, as shown in the video at the bottom right, we monitored the recovery, the remains recovery operations by using a custom device based on a cable cam to create like a four-dimensional cartographic support for locating all the elements. And both experiences are presented as articles in the journal special issue. Then another fundamental aspect of our approach is the transition from the digital representation to the multidisciplinary knowledge. And this involves integrate several interpretative layers coming from researchers within the digitization of material objects. So we conducted very large-scale experiments with a 2D and 3D annotation method by using the Aioli platform developed in my lab to spatialize and to distribute over time observation coming from different working groups and the related data. So this enabled us to use tens of thousands of spatially organized photographs representing multiple temporal states and integrate observation from various researchers while focusing on nomenclature, and controlled vocabulary issues. So the annotation corpus includes today more than 14,000 annotations within more than 250 projects available on the web in a collaborative platform. So a major effort was the digital translation of the diagnostic assessment conducted by the project management team for the architects in charge of the restoration and covering the exterior and the interior of the cathedral that you are seeing on the screen now. All the annotations, the data include the identification, the analysis of deterioration patterns or weathering phenomena, the descriptions of the previous restorations, the decoration, the stained glass windows, the instrumental measurements such as the radar analysis and the stratigraphies, and the proposed intervention promoted by the architects. So on the initial descriptive layer of the entire cathedral, additional study and descriptions layers from the scientific project have been gradually added. So these projects advance in a parallel way and cover, as you can see, overlapping aspects, including the repertoire of the lapidary marks, more than 1,000 lapidary marks memorized by the emotions working group, the remains of the polychromy on the portals, the location of the timber remains after the fire, the precise locations of the studied wooden elements, and additionally hundreds of annotation on the lead joints and of the high windows and also on the staples of the gutter walls by the metal working group have been integrated. So to clarify the scientific significance of our current and future works until 2027, you can consider just these single photographs on the screen. So along with all the branches visualized by explicating layers of observations and interpretation on the same portion of physical space. So these layers manifest through concepts, descriptive attributes, vocabulary terms, and study protocols, the way in which several disciplines look at the same objects. And you can easily understand that what one single image can be the starting point for multiple analysis and interpretations that can give us the possibility to explore, to understand the richness and the complexity of the multidisciplinary approaches. And I will conclude with this image on the right, which resembles as a galaxy. But this is a graph produced by spatializing over 7,000 vocabulary terms and sentences from the articles in the special issue for the Journal of Cultural Heritage, covering parts of the cathedral, construction details, materials, deterioration phenomena, scientific inquiries, the methodologies, the research protocols, the instruments, the disciplinary fields, and how the connections between these terms, these concepts, reflect each article's research perspective. And so this illustrates, in my opinion, the analytical challenge of this new data territory, which, while focused on a single monument on Notre-Dame, could extend to other material and knowledge objects. So we have over 3 years of research now to explore this new scientific matter, aiming to materialize and associate this cathedral of knowledge with the physical cathedral through the digital approaches. Finally, here you can see the names of all the members of the digital data working group as well as the main collaborators. Thank you very much.
Thank you, everybody. Maybe it's time for any question that could have arisen.